In looking at some of the practice for Section 12.4, applications involving quadratic equations, some of these can get to be quite challenging. Again, hopefully you have the quadratic formula under your belt, but what we need to do here is to work on a strategy that really helps us get to the equation. So as we read it, here's the total number of seats in the auditorium. Now they're saying the number of seats in each row exceeds or is greater than the number of rows by 11. Now if we wanted to find the total seating, it would be the number of rows times the number of seats. So we're going to say that x is the number of rows and x plus 11 would be the number of seats in the row, and the product of that equals 2622. Now, then our equation pops out here. This is going to be x squared plus 11x, and we just transpose this number, negative 2622 equals 0. Now, since this is going to be an even number of seats and rows and things, not necessarily even, but whole numbers, this could be factored. And you're looking for two numbers whose product differs by 11. And that's going to take some time, and we could use that method of 2622, and I'll pause while I work on that. So I got to 2 rather quickly, and then I used the rule of threes to take a 3 out of there. Then I got this, and I tried going up the different denominators, because I knew this had to factor. And then finally 19 went into this 23 times. So 2 times 23 is 46, and 3 times 19 is 57. And again, that took me a long time, so I don't know how much time you have to do these, but maybe the quadratic formula would have been the better bet. So anyway, this would need to be positive, and this would need to be negative. Now remember, when this comes out, the number of rows is what x is. So when I solve this, this is 46 rows. But they want to know how many seats. Now it comes out of the equation as a negative 57. We're going to reject that. We're going to use the 46 and add 11 to it and get 57 here. And that's our answer. And they are agreeing with our work, but this took me a long time. But I wanted you to go through the process with me. And of course, you could go to the tutor down here, and that would be helpful. Now, here is another that we did in the video series there, the PowerPoint slides, of a mountain climbing group that was going on a trip, and if everyone went, it would cost $3,000. But prior to the trip going, 3 members decided not to go, so this increased the cost per person to $225. So how many people went on the expedition? So again, I did one like this before, but I'll do it again because these are rather challenging. So we know that if it's $3,000, and if we divide that by the number of members that we're going, which we don't know, that would be X. This would give us the average cost. But now we're going to have to take that $3,000 and divide it among the actual members that are going, and that's going to be X minus 3. So if we subtract this amount, this is the lesser amount, this is the greater amount, because now each person is paying more because our denominator here is smaller. The difference will be the average of these would be 225. So that's our basic equation. But now the key is, how do we solve it? Now once we find X, by the way, we're going to have to subtract 3 from that X, because they just want to know how many people are going. So I'm going to change colors, and this is a technique we haven't worked on that much. What do we have to do to get rid of our denominators here? There's a 1 under here. Well, we have to multiply each term by the least common denominator, which is an X and a X minus 3. Now, when I do that, I multiply this by this. Here the X minus 3 cancels out, and I'm just left with 3,000X for this first term. Now here the X cancels out with this X, but now I have to multiply this by this term. So this is going to be, and let me just do that. And here it's going to be, in a sense, this X goes away, and it's X minus 3 times a negative 3,000 gives you a negative 3,000X, plus negative 3 times negative gives you a positive 9,000. And then over here, I have to multiply everything on this side by X squared minus 3X. In fact, let me write it again here just to show you. It'll be X squared minus 3X. I'm multiplying this by what's here, and I get 225X squared minus 675X. Now, a little bit of a bonus in a sense, these just cancel out. But to put this in standard form, I have to bring that positive 9,000. It becomes a negative 9,000. And then I looked and I said, well, I could take out a 5, but I could also take out a 25, which I did. And then I saw I could take out a 3 also. So theoretically, I could have taken out a 75 from each of these just to make it a little simple. And then I ended up with this. Now, I couldn't take out anything else here. Yes, I could. Let me take out some more stuff. Now, that would have worked the other way, but this way is still a little easier. So these are my factorizations. And when I go to solve, equal each of these to 0, equal this to 0, I get X equals here a negative 5, and I get X equals here a positive 8. Now remember, X was the original number to go on the trip. We wanted it with, when we subtracted 3 from the original number. So here, X minus 3 is going to be 5. 5 are the people that I'm going to put in here, and we'll see if we're right. And 5 is the correct answer. And if you need to rewind this and work it, that would be probably a good idea. This was rather challenging. Now, I went back to look at another type that we haven't worked on particularly, and I didn't go over this in the PowerPoint slides. It's two companies working together can clear a parcel of land in 8 hours. So the way these are set up, it's 1 out of X. We don't know what company A would do, but company B would take 2 hours more if it had to. So in a sense, what we're doing is looking at rates. So this is company A, this is company B, but working together, they can get the job done in 1 out of 8. So there is our basic equation and the model for solving these. So again, how do we solve them? Well, it's a matter of multiplying each of the terms by the lowest common denominator, which is going to be 8 times x times x plus 2. So I'm going to multiply each of these and then get back and show you what I've done. So the algebra is not too bad here. Let me just change colors here a little bit. Now we're going to cancel the x with this x over here. So we're left with 8 times x, which is 8x, 8 times 2, which is 16. Now in this next item, we're going to cancel out the x plus 2, which is this one right here. So we're just left with 8x. Now, for the last item on the other side, we're going to cancel out the 8 with this, and we're left with x squared plus 2x, which is when we multiply these together, and it's a 1, so it's this. So now we're going to move everything over to the other side. This is going to be 16x here. On this side, a negative 16x and a 2x gives us a negative 14x. And then we bring our 16 over to this side, it becomes a negative 16. So that's not too bad. Now, looking at this, this is not going to factor. So I put it in the quadratic formula, and I ended up with x equals 15.1. But I'm going to put in our answer, and let's see how it works. And I'm pleased to say, let me clear it up, that is good. Alright, so again, I'm trying to give you some strategy for solving these kinds of problems, just some extra little bit of a lesson. Hopefully it's helpful.